Hi, my name is Sean Ra, and I'll give you a mini lecture about neuron action potential. So let's first look at the prototypical neuron. We have dendrites here, and a cell's body, also called soma, and a long thing, which is axon. So dendrites receive signals from the other neurons, and those signals are incorporated in the soma. And when those signals goes over a threshold, it fires an action potential. Those action potential follows along the axon until the axon terminal, which is the end of the axon. So if you look at these two neurons, dendrites would receive a signal from another neuron, and those signals are incorporated here, and it goes over a threshold, it fires an action potential, and follows along the axon and gives those information to the next neuron. Next neuron is called postsynaptic, and the previous neuron is called presynaptic. And we're going to talk about action potential here. So let's look at the membrane here to know how these works. In general status, when there's no specific influence to the neuron, the inside, also called intracellular space, are negatively charged compared to the outside extracellular space. The reason is the sodium-potassium pump moves 3 cation of sodium to the outside and 2 cation of the potassium inside. So 3 positive goes out while 2 positive comes in. So that makes the inside negative. Also, there are other channels like potassium channels, sodium channels, and chlorine channels. And these are the channels that is different from this sodium potassium pump. These are only for potassium, this is for only sodium. And there are other ions like calcium and other ions in the inside that contributes to the overall net charge. But since we're talking about action potential, I'm going to talk about sodium and potassium mainly. So there are two factors that affects these ions movements. The first one is the diffusion. High concentration to low concentration. They want to move to the lower concentration. The potassium is high concentration in the inside compared to the outside, so they want to move to the outside. Sodium has a high concentration on the outside, so they want to move into the inside. The second factor is the electrostatic pressure. The same charge kind of repels each other, and the opposite charge pulls each other. The positive potassium are repelled by the outside positive and also pulled by the inside negative. By contrast, sodium are positively charged at the outside. So inside negative pulls the sodium inside and also repelled by the positive to the inside. And these channels are not always open. As I said, when dendrites receive signals from the other neurons and those signals are incorporated in the soma, when those incorporated signals makes this inside negatively charged more positive, usually to the minus 55 millivolts. We can think that resting membrane potential is minus 70. When it goes to minus 55, which is the threshold to make this sodium channel open, the sodium comes in. When sodium comes in, the cation comes in, the inside of the membrane becomes positive. And these are called depolarization. And when sodium comes in, when depolarization is at the end, sodium channel shuts down. Also, the potassium pumps are open after the sodium channels are open. It has a more higher threshold than sodium. When sodium channel shuts down, it shuts down really fast. The opened potassium channel makes the cation to leave, which is potassium. Because cation leave, the outside becomes more positive and the inside becomes more negative. This is called repolarization. The interesting thing is that sodium channel would not open again until the potential goes beneath the resting state. So this is called absolute refractory period. So there can't be another action potential firing until the potential goes under the resting state. The reason why there's more depolarized state right here is due to the potassium going out. Potassium doesn't shut down like sodium channel very fast. It gradually shuts down. So the left potassium diffuses away and making more depolarized state. After potassium channel is shut down, the sodium potassium pump will make the resting state again. That kind of regulates the net charge. So when one space of the space is depolarized, those depolarized will move to the other neurons, making this part also depolarized. Like cations move here and make this again goes over a threshold. However, the space that was depolarized goes to an absolute refractory period, which means sodium channel doesn't open again. Which means this makes the one direction of the travel of the action potential. Another thing to think about is myelin. It insulates the axon. So the space that are exposed to the outside, like, are called node of Ranimer. Only this space can exchange ions. This kind of makes the action potential skip like a big step, big footsteps to make the action potential much more faster.